Isixukuka sinzuluzo bomnyama ufihlakeli ukukhanya wakadula watshona ngapha nangaphi zamophana wadathisa ngamendu wajonga endleleni kubulwazi buza kwabaphambili ayiloliswile lazibona inyimbizi zabacudisiweyo bengenamthethileli ezisikhalazo ngempatho yenkohlakalo ukwenza okubi phansi kwelanga lendalo inxalenye yamashwa obubomi kukungaboni kweyela kuthunzula bangasenakuthetha nokunjalo ithemba limbindi nalo ihlala lihleli kundikhoyo kaloku abantu bagwenxa sibejolisile ngesaphetha esineto ejoli kulidubula ilungisa litshabalale ngeziyolo every walk that might change their minds there's no time see I'm flipping and turning dodging wrong ways before my eyes
uhile uphumile singongolweni sathanda thatha uhlala phansi usuke endleleni dala mfuna ukhanya lapha kume.
Welcome back, grade 10. Now we are continuing with our question. So I think we said we are going to do 4.3 in the next video. So now we are continuing with 4.3. So 4.3 is saying that the element P now reacts with oxygen to form a compound with a chemical formula P2O. Now 4.3.1 says now predict the chemical formula that element Rb, which is rubidium, is in the periodic table will form when it reacts with oxygen. So they said element P, remember element P was sodium. So they said now when sodium reacts with oxygen, when sodium, this is sodium, reacts with oxygen, it forms Na2O. So this is what they are saying here, because sodium is said to be element P. So when they said P2O, that means it's sodium 2O. So they said now what will now the element Rb form when it reacts with oxygen? Okay, now let's look at this one. So we want to check how does or what is it formed when oxygen react with the sodium. So this is sodium, this is oxygen. So I want to know how that compound Na2O came about. So we ask ourselves which group is the sodium and which group is the oxygen, and what is the valence electron of sodium and how much electrons does it want to share, how much electrons does oxygen wants to share. So let's look at the periodic table. Okay, so this is sodium, this is sodium. So you can see sodium is in group 1 and it wants to donate 1 electron. Now this is oxygen. Oxygen is in group 6, but it wants to receive 2 oxygen. So we're going to take now these subscripts and then put them on top of the sodium and on top of the oxygen. So we said oxygen, sodium is in group 1, it wants to donate 1 electron. Oxygen is in group 6, it wants to receive 2 electrons. So that means that oxygen wants to receive 2 oxygens, but sodium can only donate 1 oxygen. So that means that oxygen needs 2 sodium so that it can be filled. So this is what is going to happen now. You're going to have sodium, which are 2, and oxygen, which is 1, because sodium can only donate 1 electron, but oxygen needed 2 electrons. So it's like oxygen needed another sodium. Then these 2 sodium will react with that oxygen to form Na2O. But if this is difficult for you, just do this. So just take this one, put it here. Just take these 2, put it there. So it's like now you have Na2O. So it's the same thing. Let's say that you have an example where you had the magnesium, which is in group 2. It's reacting, let's say, with oxygen. Okay, not with oxygen. Let's say it's reacting with fluoride, which is need -1. So just take these two, put it there. Just take this one, put it there. So you can make your life easy this way, because this magnesium needs to donate 2 electrons. That means it needs another fluorine to donate the second electron, because fluorine can only accept 1 electron. So just do this crisscross multiplication something, then your life would be easy that way. So this is how they got this Na2O. Now they are asking now if rubidium is reacting now with oxygen. It's like we have something like this now, Rb plus O. Then what is it going to form? What will be the compound that will be formed out of that reaction? So let's look at this reaction. Okay, so this is the reaction, Rb plus O. We need to check now where is Rb in the periodic table, and then we apply our knowledge. Now here is Rb. Now you can see that Rb is also in group 1, which means it also wants to donate 1 electron. Oxygen, we said it wants to receive 2 electrons. So we're going to put +1 here, going to put -2 here. So it's easy now, you know that we're going to take the 2, put it here, take the 1, put it there. So you're going to have Rb2O1. So it means that you need 2 rubidiums to react with the oxygen. You need 2 of these to react with oxygen. So this is the reaction that will be formed when Rb react with oxygen. It's going to form Rb2O. That is the answer. So we go now to the following question. Explain the answer to question 4.3.1. So let's explain now this answer, why we said it's going to be Rb2O. So the reason is that Rb is in group 1. It has a 1 valence electron. That means that you needed 2 rubidium atoms to react with oxygen, because oxygen is in group 6 and it needs 2 electrons in its valence orbital. So you have to write that in words. To make life easy, because of this sodium is in group 1 and it formed this compound, and this rubidium is also in group 1, it formed a similar compound. You can say there, because the reason we got that compound is because Rb is also in group 1 as sodium. It has the same valency as sodium. Yeah, you can also put it that way. You're gonna get that 2 marks. So 4.4 now said, what is the trend in ionization energy as you move from element P to element R? Write down only increase, decrease, or remain the same. Explain the answer. What is the trend in ionization energy as you move from element P to element R? So this is element P, element Q, element R. So we want a trend now as we move from P to R. What is the, remember, P is sodium, Q is silicon, and R is sulfur. So what is the trend in the ionization energy? So we need now to explain what is ionization energy. Okay, now ionization energy by definition, this is ionization energy. We said ionization energy is the energy required to remove an electron from an atom in a gaseous phase. Yeah, that is a definition. I'm not sure if you can see this. Let me make it bigger. Yeah. So we said ionization energy is the energy required to remove an electron from an atom in a gaseous phase. So if you look at the arrow here, the arrow says this way the ionization energy is increasing, but down this way the ionization energy is decreasing. In other words, in the periodic table, if you look in your periodic table, they're saying that if you move this way from left to right, the ionization energy is increasing. That means the ionization energy of sodium, remember we are looking at sodium, we are looking at silicon, we are looking at sulfur. These are our elements P, Q, R. So that means the ionization energy of sodium is smaller than the ionization energy of silicon. The ionization energy of silicon is smaller than the ionization energy of sulfur because of its increasing this way. But if you go down the periodic table, then that means the ionization energy of sodium is bigger than that of K. That of K is bigger than that of Rb. That of Rb is bigger than that of Cs, etc. So now we want now to answer that question. What is the trend? So you can see the trend that the ionization energy is increasing from sodium to sulfur. That is the trend. Then explain this now, why it is increasing this way. Then we need now to look at the second arrow here. Look now, the arrows on the left is talking about the atomic radius. This is the atomic radius, AR. The atomic radius is the distance between the nucleus and the outermost orbital. The distance between the radius and the outermost orbital, which means that the arrow here is saying from left to right, the atomic radius is decreasing. What that means is that if you look at the sodium, that means the radius of a sodium is like this. In other words, from the nucleus of the sodium to there, that is the atomic radius. That is the atomic radius. It is very big. But now if you look at the following, like silicon now is smaller than sodium. From here to there, it's very small. This is silicon. Then the one for sulfur is like this, which means from the nucleus to the outermost valence orbital is very small. So as you can see now, if you have like one electron for sodium in the outermost energy level and you have the nucleus here, it means that this electron, which is at the outermost orbital from the nucleus, is far from the nucleus. Remember, in the nucleus we have positive protons, here you have negative electrons. The force of attraction here will be very weak because of this electron is far from the nucleus. But for sulfur, the electrons that are at the valence electrons are very much close to the nucleus. That means here, that's why the ionization energy, we said it's very strong. It's very strong here because of the electrons are very much closer to the nucleus. Even here for silicon, the valence electrons are very much closer to the nucleus. So the ionization energy of this one is stronger than that of this one. The ionization energy of this one is stronger than that of this one. So the ionization energy of this one is very weak compared to the silicon. That of silicon is very weak compared to that of sulfur. But the atomic radius of sodium is bigger than the atomic radius of silicon. The atomic radius of silicon is bigger than that of sulfur. So this electron is far apart. That's why the ionization energy is weak. This electron of the sulfur valence electron are very much close to the nucleus. That's why the ionization energy is strong. So this is how we explain the ionization energy. So those atoms that are far on the right have a stronger ionization energy because they have a shorter atomic radius. The atoms that are on the left, they have a weak ionization energy because they have a greater atomic radius. I hope this makes sense. So that's what now we need to do to answer this question. What is the ionization? What is a trend in the ionization energy? Now I'm not gonna write this one. I'm just gonna explain it. I'm saying the ionization energy from sodium to sulfur is increasing. Why it is increasing? Because the atomic radius from sodium to sulfur is decreasing. What that means is that you need more energy. You have to write this down now. You need more energy to, less energy. You need less ionization energy to remove an electron from the sodium valence orbital. But you need stronger ionization energy to bond an electron in the sulfur, something like that. So that's how you need to answer that question. I don't have a space here to write that down. The first point, that the ionization energy from sodium to sulfur is increasing because the atomic radius from sodium to sulfur is decreasing. Then you need less ionization energy to remove an electron from the valence orbital of the sodium. So that's how you answer that question. I hope you can understand. So let us now move to 4.5. 4.5 says, how many electrons does an ion of element P have? Draw an Aufbau diagram of this ion. Draw an Aufbau diagram of this ion. Okay, so here they ask us how many electrons does an ion. Remember what we said about ions. The ion of element P. Remember what is element P? Go back to the table. Element P is sodium. This is element P. What is an ion of sodium? Since it's in group 1, then the ion we know is going to be Na+. So that is a ion for sodium. How many electrons now does that have? So go back to the periodic table. Now this is sodium. This is sodium. How many electrons does sodium have? According to the periodic table, there are 11 electrons. But it's in group 1, it wants to donate 1 electron. So after it donated that 1 electron, is going to become an ion, which is Na+. Now this plus means that it has donated now that 1 electron. So if there were 11, now there are 10. So now we have 10 electrons for sodium. So they are saying this question now, Now, how many electrons does an ion have? We said now it has 10 electrons. Now, draw an off-bow diagram of this ion. In other words, the ion of sodium that has 10 electrons. We need to draw now the off-bow diagram. What is the off-bow diagram? Okay, yeah, here is the off-bow diagram. This is the off-bow diagram. So the off-bow diagram shows the energy levels in the orbitals of the electron, of the atom. Okay, let me, for example, check what atom we're going to draw. Okay, we're going to draw a sodium ion. Okay, so this is the sodium ion that we want to draw in the off-bow diagram. We said this sodium ion has 10 electrons. So if we are drawing the Bohr model of this atom, the Bohr model of that atom looks like this. So this sodium, remember the sodium according to the periodic table, it has 11 electrons. This is the sodium from the periodic table, 11 electrons. So I want to draw the Bohr model of the sodium first with 11 electrons. We know in the nucleus, the first energy level, you see this first belt, the first orbital, is going to have 2 electrons. This is the first orbital. So this first orbital, we call it the 1s orbital. So it's this one. So the first one is 1s. So these 2 electrons, I have to draw them now in this 1s orbital. So each block now represent the, okay, let me do it this way. Yeah, so each block, this is one block, it must have 2 electrons. So the Hans rule, there is a rule that you must follow here. It calls the Hans rule. So it says that you must first fill the S like this. The first electron must have the arrow that is going up. Then the second electron must have the arrow that is facing down. It's because of they are spinning in opposite direction. It's difficult to show you in the diagram. It's like this is like something like this. So they are spinning like in the other one spinning that way, the other one spinning that way. Don't worry about that one. But when we represent it in the off-bow diagram, the first one looks up, the second one looks down. So we're done with the first orbital. Now we go to the second orbital. So according to Bohr model, this is a Bohr model of an atom. So the first core electrons are in the first belt. There are only 2 first orbital. So the second orbital is going to have 8 electrons. 3, 4, 5, 6, 7, 8. So this is now the 2s, 2p. All 8 of them are in the 2s, 2p. In other words, now we are looking now at the second orbital. This is the second orbital. Remember, this one is the first orbital. Now this one is the second orbital. So we want to fill this one with 8 electrons. How are we going to fill the 8 electrons? We are going to follow Hans rule. So in the 2s orbital, we're going to have 1 looking up, the second one, 2 looking down. Look, now we have 3 blocks now on the 2p level. So we're going to say 1, 2, 3. You must first fill those ones looking up. Then you come back, you said, remember 1, 2, 3, 4, 5, 6, 7, 8. Yeah, now they are 8. Let me do it again. So you want to fill 8 electrons. So you start with the 2s, 1. You come back with the second one, 2. You go to the 2p, 3, 4, 5. Then come back here, 6, 7, 8. So you must first fill the 2s before you fill the 2p. So this is how you fill your orbitals, your electrons in the blocks in the Aufbau diagram. Now we're going now to the last valence orbital. Remember, we have now 2 plus 8, that's 10. According to the periodic table, sodium is supposed to have 11. So the last orbital is going to have now 1 electrons to make it 11 electrons. So according now to the Aufbau diagram, you just have to go to the 3s now. This is the 3s, which is a third orbital. You just fill that one like that. So all of them now, they are 11 electrons. This is how it would look like if we were to draw the sodium atom in the Aufbau diagram. But they said in our question, we need to draw now the ion of the sodium. So how many electrons does an ion have? It has 10 electrons. That means you just have to take this one out now. So we take that one out. So now we remain with 1s, 2s, 2p is 2, 4, 6, 8, 10. It's gonna give us 10 electrons. So this will be the Aufbau diagram of the sodium ion. It will be like this. Let me give you 2 more examples. This is the answer for that question, but now I want to do something extra in addition to this example. Let's say that we are required to draw the Aufbau diagram of the, let's choose potassium, for example. Yeah, potassium got 19 electrons. So let's do an Aufbau diagram of potassium. Okay, now this is the potassium atom. It has 19 electrons. So we want to draw now the Aufbau diagram of the potassium atom in the Aufbau. So let's look at the first at the Bohr model. So the Bohr model says the first belt will have 2 electrons. So it's 1, 2 electrons. We know this is the 1s orbital. So you come here, you said, okay, I have 1, 2. Then we are done with 1s orbital. So you go to the next orbital, which is second orbital. This is a first, go to the second. This is a second orbital. The second orbital must have 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. So this is the 2s, 2p. So you come here to the second orbital, 2s, 2p, second energy level. Then you said, okay, I'm going to fill this one with 8 electrons. Remember, here you only fill 2 electrons. These are your core electrons. They don't bond, these ones. So this is a second orbital. It has 8 electrons. How do you fill the 8 electrons? According to Hund's rule. So Hund's rule says you must first fill the s orbital. 1, 2. Then you come to the 2p. 3, 4, 5. Come back. 6, 7, 8. So we are done with that one. Then we go to the third orbital. 1, 2, 3, 4, 5, 6, 7, 8. Now we are on the 3s, 3p, which is a third one. Now we are here now, which we are in the third orbital. It must also have 8 electrons. So we fill it. 1, 2. Then we are done. 3, 4, 5. Come back. 6, 7, 8. So we are done with the third orbital. How many electrons now? 2 plus 8, that's 10. Plus 8, that's 18. So we only need 1 now. So the fourth energy level is going to have only 1 electron. It's going to have 1 electron to make it 19. Now we have 19. So the fourth is going to be the 4s orbital. So we come here to the fourth orbital, which is a valence orbital. is gonna only have 1 electron because it's only a 19 electrons. So that's how we fill in the Aufbau diagram for the potassium atom. Okay, now for the last example, now I'm going to do the atom which is Cr atom. I think it's chromium. So this one, Cr, I think it got 24 electrons, 52 mass number. Yeah, so we want now to draw the chromium Aufbau diagram. It has 24 electrons. So we're going to use the same table here. So the first one, we're going to have 2, 4, plus 6, that's 10, plus 2, that's 12, plus 2, that is 18, 19, let me use the same color, 20, 20, 21, 22, 23, you come back here, 24. So this is how the chromium atom Aufbau diagram will look like. The first one we have 2, then you come to the 2s, 4, you come to the 2p, 4 plus 6, that's 10, plus 2, that is 12, plus 2, that is 18. When you come here, you said 19, 20. You go to the 4p, 21, 22, 23. You go back to the first one, 24. So this is how you fill the Aufbau diagram. So yeah, I think we are done with that question now. That was asking, let us draw the Aufbau diagram for the 10 electron ion sodium. I showed you how to do this one. So now I'm doing 4.6. 4.6 saying now, when orbitals of identical energy are available, electrons are placed in individual orbitals before they are paired. Give the name of this rule. I explained that one is Hans rule. You must first fill they said electrons are placed in individual orbitals before they are paired. You remember this is how Hans rule says. You must first fill each electron in its individual orbital before you pair it, then you pair that one, then you pair that one. That is Hans rule. So last question now, element Y occurs as these isotopes in the following proportion. Y has this isotope, another Y has that isotope, Y has that isotope. Now an isotope, what is an isotope? Before we go to the question, an isotope, here is a definition. Isotope, define isotope as atoms of the same element having the same number of protons but different number of neutrons. So that is an isotope, is the atoms of the same element. For example, let's say we have sodium. Let's say we have sodium. This is sodium. This is sodium. This is sodium. It's like twins, né? So isotopes are twins. Now, the atom of the same element having the same number of protons, so it has 11 protons, but different number of neutrons. Now remember, in the mass we have neutrons plus protons. So if the different number of neutrons is going to make a different number of molar mass. So the first sodium has 23 mass number, the other one have 24 mass number, the other one have 25 mass number. So the same number of protons but different number of neutrons. If you have different number of neutrons, we're going to have different mass number. So we call these isotopes. Isotopes are atoms of the same element, same number of protons, different number of neutrons. So they are saying here now, element Y occurs as these isotopes in the following proportion. So we have the first Y with, look at it, it is 28. That's the mass number. the other one has 29, the other one has 30. So different mass number, but same number of protons. So what was element Y? Element Y, okay, I think it's a new, okay, yeah, element Y, they didn't tell us what is element Y. So they just say calculate now the relative atomic mass of element Y. Now remember, element Y, the first one has this percent, the second one has that percent, the third one has that percent. So let's find the relative atomic mass of element Y. So to calculate the relative atomic mass, we use this formula. Relative atomic mass is equal to, you look at the first atom, which is 28, you multiply it by its percent, which is 92,23, plus you take the second atom, which is 4,68, you multiply the mass by the percentage, you take the third atom, which is 30, you multiply it by the percentage, which is 3,09. All of that, we divide it by 100. Then you press all of that in a calculator, then you divide by 100, the answer will be, so you'll get 28,11, that is the relative atomic mass, which will be grams per mole. So this is the relative atomic mass of this. So if you go to your periodic table and check what element was element Y, so you can see element Y was silicon. Look at the mass number is 28. So that means that the isotopes of silicon will have, the first one will be the one that we have for 20. The first one was 28, the other one was 29, the other one was 30. If you look at the relative atomic mass of all of them, it will give you 28,11. That means here we are dealing with silicon. This is element Y is silicon. Yeah, that is the end of our question. So I just want to explain one thing that I did not, it was not asked in this question. It's called electron configuration. So let me just explain this concept in case they ask you in the future. Okay, if they ask you to write maybe the electron configuration of this chromium atom, you can only write the electron configuration from the Aufbau diagram. So I'm going to write here the electron configuration. So this is how you do electron configuration. Now look at the first orbital, the 1s orbital. So you said 1s. How many electrons in the 1s? There are 2 electrons. So you said 1s to the power 2. Then you go to the 2s orbital. You said 2s. How many electrons in the 2s? There are 2. Then you go to the 2p orbital. You said 2p. How many electrons in the 2p? There are 6. You go to the 3s orbital. You said 3s. How many electrons in the 3s? There are 2. You go to the 3p orbital. You say 3p. How many electrons there? There are 6. You go to the 4s orbital. You said 4s. How many electrons there? There are 2. You go to the 4p orbital. You say 4p. How many electrons there? 2, 4. There are 4. So we call this now the electron configuration. It's written this way: 1s to the power 2, 2s to the power 2, 2p to the power 6, 3s to the power 2, 3p to the power 6, 4s to the power 2, 4p to the power 4. So the electrons are represented by these exponents, or power of. So we call that electron configuration. So if we were to write maybe for our ion, which was sodium ion, which has 10 electrons, so the electron configuration of this one, remember, it would be it would be this one, 2, 4, 6, 8, 10. It would end here. The Aufbau diagram, it would end here. Then how to write the electron configuration of the sodium, 10 electron sodium ion. Then you would do it this way. So you would say electron configuration, it's 1s. 1s has 2 electrons. You go to 2s. 2s has 2 electrons. You go to 2p. 2p has 6 electrons. So this is the electron configuration for the sodium ion. But what about the sodium atom? The sodium atom has 11 electrons. So that means that you're going to move up to now 3s1, because of now there are 11, 2, 4, 6, 8, 10, 11. It was going to end here. You would not have this one and those ones in the sodium atom. In this one, going to have 11 electrons, so it's going to be 2, 4, 6, 8, 10, 11 in the Aufbau diagram. Then the electron configuration was going to be 1s2, 2s2, 2p6, 3s1. Yeah, that is the configuration, electron configuration. So this is the end of our question. So now I will see you when we are doing now the ionization energy in the next video.
Zinsuluzo bomnyama ufihlakele ukukhanya wakadula watshona ngapha nangaphi zamuphana watathisa ngamuntu wajunga endleleni kubulwazi buzo kwabaphambili ayiloliswile lazibona inyimbizi zabacudisiweyo bengenamthithilini izikhalazo ngempatho yenkohlakalo ukwenza okubi phansi kwelanga lendalo inxalenye yamashwa obubomi kukungaboni kweyela kuthunzi labangasena kuthetha nokukunjalo ithemba limbindi nalo ihlala lihleli kundikhoyo kaloku abantu bagwenxa sibijolisile ngesaphetha esineto ejoli kulidubula ilungisa lichabalale ngeziyona every work that might change their mind, there's no time. See I'm flipping and turning dodging wrong ways before my eyes.
Uhile uphumile singongolwe sathana thatha uhlala phansi usuke endleleni sala mfuna ukhanya lapha kume